Now we're going to talk about a really interesting number called e, and the e represents a number. It's a letter that represents a constant, much like pi is a Greek letter that represents a constant. This is also it's also an irrational number. But let's just take this compound interest type formula here. We saw that earlier, and think about if you were to compound something once in a year, you would get you get this result. If you did it twice in a year, you get 225. If you were to compound something 4 times in a year, you get 244. If you were to compound something 12 times in a year, you would get 261. If it was every single day of the year, I'm not going to argue about leap years or whatever, 271.4567. If you did it, I don't think that's not per second, but maybe that's per minute. You get 271.8127. I think it's interesting that even though you went up by a huge factor there, it went 2.714 to 2.718. Okay. And then we have going to 525,960, and then doing the compounding that many times. Oh, here it is in front of me. So daily, hourly, per minute. You get this 271.8279. So it changed at that after the 8, the digit changed. If you do it every second, you end up with 271.8282. So that's the same. It changed here for that digit. So the point is, if you were to do this more and more and more and more, it changes. It reaches a point where it stops change. It changes, but very small changes. So if we were to take this number e, and which could be represented as 1 point plus 1 over n to the n power, and you take n going forever. Now in calculus we say n increases, or this says n increases without bound. We would say take the limit as n goes to infinity. Then you get the letter e, which is uses the base for many real-world exponential models. To work with the base e, we use the approximation e is approximately 2.718282. But like I said, it goes on forever. It never repeats, never terminates. It's an irrational number. The constant was named by Swiss mathematician Leonard Euler. Or sorry, that's actually pronounced Euler. My mistake. Please don't hate me in the comments. From 1707 to 1783, that's when he was alive, who first investigated and discovered many of its properties. So you have this button on your calculator. We want to calculate e to the 3.14. So you take out your calculator and you do e and the caret button. E usually will give you a place for an exponential, 3.14, and that's going to be approximately 23.10387. Okay. So that's the idea of base e, and I want to just really stress that it's the idea here that e is born out of this expression. If you take and do compounding an infinite number of times, you get the e value. Okay, in the next video we're going to talk about investigating continuous growth. That is using this e as a base.